At the beginning of this topic, I introduced the idea that work leads to a change in energy. And then we learned how to calculate what work is. So work is force times displacement, where we understand that the force and displacement must be parallel to each other in order to cause work to be done. And so we insinuated by applying a force over distance, we're going to lead to the energy in the system changing. But now we want to get into how do you calculate energy and the different types of energy. So we're going to start with our work equation here. So work equals force net times displacement. And we learned in the previous topic that force is equal to mass times acceleration. Alright, and we learned in the first unit that acceleration can be found by taking the first derivative of a velocity function in terms of time. And I'm going to replace delta d with a microscopic change instead of a macroscopic change. And we do that by using the lowercase d rather than a delta of a position function in terms of time. And I'm leaving these generic rather than specifying x or y. Alright, so what I'm going to do is rearrange. And essentially I'm going to rearrange my numerator a little bit so that I'm associating the position function in terms of time with the denominator of taking the derivative in terms of time. And I'm sort of leaving out hanging here the incremental change in the velocity in terms of time. And this then allows me to say the derivative in terms of time of the displacement function is velocity in terms of time. And now we have just an incremental change, which means I can integrate. I'm going to pull the mass out front because the mass is a constant, and I'm going to integrate from v initial to v final. And that's going to lead me to end up with v initial to v final. We need to evaluate 1/2 v squared. So when I evaluate, I end up with 1/2 mass times v final squared minus v initial squared. And I can rewrite this with the 1/2 and the mass distributed. And this is what we refer to as the work-energy theorem. And what that means is because work is leading to a change in energy, we have a change from a final to between a final and an initial here. So that means this term must be a final energy and this here must be an initial energy. And we're going to refer to this type of energy, 1/2 mass times velocity squared, as the kinetic energy. And remember, anytime you see the word kinetic, that kin sort of beginning of the word, that is motion. So this is the energy the object has due to its motion. We can also then rewrite the work-energy theorem by saying work equals the change in kinetic energy. Remember, change in means take final minus initial.